Hi, I'm Debbie with Nixene Publishing. I'm here with Adrian Nixon from Yorkshire, England, right, Adrian?
Yep.
All right. Good morning. How are you?
Yeah, good morning, Debbie. I'm very well, thank you very much. Actually, it's good afternoon here.
True. Good afternoon. Good afternoon. Well, we are continuing our series on Adrian on the spot. And Adrian has very nicely agreed to be able to hear some of the questions that our readers have posed, our viewers have posed on our YouTube channel. Our next question from our viewer. This one is about the viewer was talking about video number 25, the fourth bond in graphene.
Ah, right. And
really just made a comment and apparently didn't get what they were looking for when they were coming to see and said, I came here because I was curious about the fourth bond on graphene. I guess I'll have to do some more reading on this. Is there something that we could talk about on the video as far as the diagram from it, or I'd have to say
model time, Debbie.
Okay.
So fourth bond in graphene, carbon.
Yes.
Remember this? So
yes,
this is the repeating unit in diamond, and it's called sp3 hybridized. We'll just park that for the minute. Okay. The point about carbon is it likes to form 4 bonds all the time. Mm-hmm. And diamond forms its 3-dimensional structure, so that repeats. So it's a bit like a 3-legged stool with another leg sticking up. Yes. And that would then have another one of these dangling down here and here and here, and it repeats and repeats. And that is an incredibly strong 3-dimensional structure. However, graphene is based on hexagons and it's flat.
Yes.
And when you actually look at, let's say, one of these bonds here, so this is a carbon atom and these gray things here are bonds. A bond is shared electrons. In fact, Debbie, we probably ought to do a video on bonds and atoms and things sometime in the future. You have to remind me about that.
Sounds good.
For the moment, let's just look at this carbon atom here. It's flat. So there are 1, 2, 3, and yet carbon likes to form 4 bonds. So where's the other bond?
Where's the fourth bond?
Well, that's the limitation of these models. They don't show you all the details. So when carbon is being drawn or even put into these molecules or even in textbooks, then it's drawn in a way that, let's take the repeating unit from graphene here, this hexagon. Yes. And the way it's drawn usually in textbooks is these bonds, some of these bonds here are double bonds and some are single bonds. So now you've got single bond, double bond, single bond, double bond, and when you actually average them all out, you end up with 4 bonds. So, but that doesn't quite tell you the full story, because if you can use scientific instruments to actually measure the bond length, and a single bond is longer than a double bond. So you can tell the difference. You should be able to see short, long, short, long. But when you actually look at the molecule with a lot of these expensive scientific instruments, you find that all the bonds are the same length. So something else is going on. It can't be single bond, double bond like that. Turns out to be a little bit more complicated. But in effect, what's going on is, let's go back to this single hexagon. It's probably easier to explain. Then I'll go to the graphene molecule itself. But what happens is that the single and double bonds don't quite form like that. They form something called sp2 hybridized carbon, which is, we have the bond sticking up and below the plane of the ring, and it forms like, it's called a p orbital, and it forms like a lobe. So above and below each one of these, we have this lobe, and what happens is they start blending into one another sideways. So these lobes interact. And what happens is those 3 double bonds smear across the whole circular unit. It's called a molecular orbital now. And so you sort of lose it in that, it becomes like a fog above and below the plane of the ring. Yeah. So if we look at graphene, we can't draw it and we can't show it very easily on here, which is why it's misleading for people. But you've got the 3 bonds here, but then each one of these atoms here has got this little p orbital sticking up, and these p orbitals all smear, and that effectively it gets smeared across the whole molecule. It's really unusual. And so that forms what's called a pi orbital, which is a molecular orbital which is effectively a bond which covers the whole surface of the graphene. It's above and below. It's all the same thing. And that's why you can't see it. And interestingly, these bonds here are called covalent bonds, and they're what give graphene its strength. And that pi orbital that's smeared across the whole lot allows electrons to whiz through very fast. And that's what makes graphene electrically conductive as well.
I was going to ask, does that have something to do with the van der Waals?
Van der Waals forces are something different, and we'll park that for another time, because that is another rabbit hole we'll go down, unless one of the viewers is asking. So does that help explain where the 4th bond is?
Yes, to me it does, especially when you're talking about how it helps to do the electrical conductivity.
Yeah.
That was a great question. Thank you so much.
Yeah, the viewers are asking smart questions.
Thank you so much, Adrian, for your time. A
pleasure, Debbie, and thanks again to the viewers for taking the time to message in. We'll try and do these a little bit more frequently now.
Okay.